Hello, everyone. I'm going to go over protein synthesis with you guys, and hopefully between this lecture and the videos that I've sent out, you guys will have a good idea of what's going on. So, protein synthesis. I'm going to give you the step-by-step of protein synthesis. The first thing that happens is happening in the nucleus. There are two steps to protein synthesis: translation and transcription. And so the first thing is transcription. That happens inside the nucleus. And it's where mRNA, which is also known as messenger RNA, makes a copy of the DNA section that it needs. Once that copy is made, transcription is over. So I'll do a little part two. This is part two here. Now we're going to talk about the steps of translation. So the mRNA leaves the nucleus and goes to find a ribosome. And that ribosome can be floating in the cell, or it could be on the rough ER inside the cell. Once it's there at the ribosome, the transfer RNA, tRNA, which uses codons, will come and from the outside of the ribosome and grab the mRNA as it enters. So it will, tRNA will grab mRNA as it enters the ribosome. With the help of rRNA, which is your ribosome RNA, it will make the protein. To help it, protein is made in ribosome. And then lastly, the protein leaves. It's ready to go do whatever it needs to do. It needs to go to the eyeball or wherever it needs to go to do its work. It leaves. Okay? So these are the steps of protein synthesis. We have translation, where the mRNA copies the DNA inside the nucleus. Then we have translation, where the mRNA leaves the nucleus, goes to find a ribosome, either on the rough ER or in the cytoplasm. Then the tRNA, which is waiting outside the ribosomes, hook up with the mRNA when it comes into the ribosome. Then, with the help of rRNA, which is the ribosomal RNA, a protein is made inside the ribosome, and once it's made, it folds and leaves. Now, let me tell you a couple of other things about this process. Okay. So let's see what page 78. Okay, if you turn to page 78 in your book, well, before we do that, let's go back. Turn to page 229. Turn to page 229. There's a great graphic here that shows you exactly what happens in translation and transcription and translation. Here is the DNA inside the nucleus, where it's making, the messenger RNA is making a copy of one side. There's the copy of one side of the DNA. It leaves the nucleus. There it is, leaving the nucleus. It goes and finds a ribosome. That brown thing's the ribosome. These little things that look like they have crosses on top of them are your codons for your transfer RNA. They're just waiting around. As the mRNA comes through the ribosome, the matching tRNA come down and hook on and make this little ball pop out on top. This little ball pop out on top. And when that little ball pops out, it is a protein, and they'll just keep on making a protein chain until the code for stop comes through. Then the protein will fold, leave the ribosome, and go do its work. Okay, so if you look on page 78, you'll remember maybe that we talked about nucleotides. We talked about pairing nucleotides. Okay? And so you need to remember that we have cytosine, guanine, thymine, and adenine. Now, normally adenine and thymine would go together and cytosine and guanine go together. But on messenger RNA, there is no thymine, there's uracil. So that replaces the T. Let me show you what I mean by that. Okay, so let's say that this protein, this is coming to the, let's say this is the DNA in the nucleus that needs to be copied. So this is the DNA that needs to be copied. So the messenger RNA will match up what it needs to. A usually goes with T. A usually goes with T in DNA, but there's no T in messenger RNA, so you have to use a U for uracil. And then there's a T here, so we're going to put an adenine there. We're going to put a guanine there, a cytosine there. We're going to put an adenine there. And then again, there's no T to put here, so we put uracil. So this is the DNA, and this is the RNA. Now, if you look on page page 228, you'll see a very long code. The first are the two parts of the DNA strand. Then it unzips this during transcription, unzips that DNA, the section that it needs, and it makes this copy for mRNA that has U's instead of T's. Then the transport RNA comes in and makes another copy, and that's where we get our codons from, little sections of 3 apiece. So let me write down what this would be. This would be A, U, C, G, U, A. This is my tRNA, and these come in sets of 3. These are my codons. Those are my codons. So this is the code for a specific protein. For example, I don't know if I have what that is. I'm not sure what that is. Well, let me teach you how to figure out what this is. So we need to figure out what protein is AUC. So if you look on page 228, you'll see that the first letter is A. So in the first column, it says first letter, we go to A. Then for second letter, we would go across to the U. And then the third letter, we would go to the C. So we would have AUC, which is the protein ILE. That's the protein that we just made. Then if we have the next one, we go to the first letter G in the first column, all the way over to U in the second column, that first little part there. And then our third letter is A, so that's 3 down. So we would be making VAL. And these are all short for really long names for our amino acids. And when we connect all of our amino acids together, when these connect, and then there's another one, and there's another one, and then remember it folds, that is when you make your protein. Okay. Let me make sure I told you everything I wanted to tell you. Okay, so I'm going to upload an activity where you are using code to determine the traits of a mythical creature. So you're going to use a code just like the one on page 228. So let me walk you through that one more time. Okay, I'll try to hold the book up, walk you through it. Okay, so here is the DNA, 2 strands, double helix DNA. The messenger, it will split, and the messenger RNA will make a copy. It will not have any T's. Where there should be a T to match an A, there will be a U instead, because messenger RNA does not have any T's. So let's look at this one right here. We have AUG, okay, because it matches TAC. So then you get your, C. So then you get your opposite of that. The T gets an A, the A gets a U, and the C gets a G. So that top strand of DNA is being copied. Now, the tRNA is going to come next. So it's going to say, okay, there's an A here. I'm going to put a U there. There's a U here. I'll put an A, and a G. I'll put a C. Now, what is this amino acid UAC? Well, I go up here, and I find my U. Then I find my A. Then I find my C. So that tells me that UAC is TYR. TYR, right here is where we land. TYR is our amino acid. So the activity that I want, so for today, you've got some videos to watch. You need to upload your amino acid protein synthesis papers and all your amino acid worksheets. You need to upload those. I have them in the grade book. There's a protein synthesis, really good video that I put on there. Plus there's some review videos about proteins, just in case you are totally lost about what a protein is and why we need proteins and how we make, what the structure of a protein is. Then you can go to those review videos and do that. So again, I'm going to upload an activity and bring that completed Wednesday to school, and upload all your Amoeba Sisters video worksheets. Okay, thanks, bye.